these problems may not look like quadratic equations. They're rational equations, right? They have x down in the denominator of a fraction. But there are quadratics lurking within these. And what we're going to do is manipulate these so that the quadratic comes out. Then we'll solve the quadratic. And then we'll have to do a little extra testing to see if all those solutions really work with our original rational equation. One thing I notice here off the bat is that I've got this subtraction problem, and I can't really subtract unless the denominators are the same. This, however, I recognize as a difference of squares. X squared minus 1 is the same as x minus 1 times x plus 1. I've got x minus 1 over here, so if I multiplied this fraction on this side by x plus 1 over x plus 1, and remember I can do that because anything over itself is 1, so that's like multiplying this by 1. If I do that, I'll have the denominator the same. So if I multiply across the top here, I get x plus 1. On the bottom, I'm going to get x minus 1 times x plus 1. Well, that's x squared minus 1. And now I can do my subtraction because the denominators are the same. Now, the thing I have to remember here is that I'm subtracting this whole thing, so it's like I distribute the negative sign and then add. So that's a minus x and a minus 1. 2 minus 1 is 1, and the minus x is a minus x. So we have 1 minus x over x squared minus 1. And I've been ignoring the right side of this equation. I'll put it back in there. That equals 1. We're in a lot better shape now. We've just got one fraction, and what I'm actually going to do is multiply both sides by x squared minus 1. And what that'll do here is cancel. When you multiply by 1 here, it's just itself. So we get 1 minus x on the left, and we get x squared minus 1 on the right. Now all we have to do is add an x, subtract a 1, and we get x squared plus x minus 2 equals 0. That's a quadratic we can deal with. In fact, I think we can factor that one. That would be x plus 2 and x minus 1. So our solutions would be x equals negative 2 and x equals 1. But here is where we have to go back to our original. Remember, with rational equations, you can't have the denominator equal to 0. Everything just blows up if you do that. And I notice with x minus 1, that would cause both of these denominators to go to 0. So x minus 1 is not going to work as a solution. Or x equals 1. X equals minus 2, let's see, well, that doesn't make the denominator 0, so that's actually going to work as a solution. All right, let's try one more. Now here I don't have a difference of squares, and to get the denominators the same, I'm just going to multiply this one by r minus 1 over r minus 1, and this one by r minus 4 over r minus 4. Then the denominators will both be r minus 1 times r minus 4. So on the top of this one, I have to multiply r minus 1 times r. I'll distribute that r right away. It gives me r squared minus r over, well, let's go ahead and multiply this out too. R squared minus 5r, might want to check my math on that, plus 4. And here we have r squared minus 4r over the same thing, r squared minus 5r plus 4, and that all equals 1. Now that our denominators are the same, we can just do the addition. So we're going to get 2r squared minus 5r over r squared minus 5r plus 4 equals 1. And once I've got it down to this shape, I can multiply by the denominator. So we're going to multiply both sides by r squared minus 5r plus 4. Over here, that's going to cancel. Over here, we're multiplying that by 1, so really we're just going to get r squared minus 5r plus 4. And now we can rearrange to make our quadratic. I think I'm going to subtract an r squared from both sides, so we get r squared over here. So add a 5r to both sides, that r term disappears. And actually, before I do anything with a 4, I think I'll just leave it over there, because I can solve this one by the square root rule. And we get r equals plus or minus 2. But let's double check and make sure they both work in this equation. Up here, if I put in 2 for r, would it make either of these denominators go to 0? Up here, it would make this denominator go to negative 2. Up here would make this denominator go to, or -6, go to 1 or -3. So actually that looks great. So both of these solutions work for that rational equation. So that's a little bit of work with some rational equations that have quadratics hiding inside them. My name is Larry. I'm a teacher at EdVisions off campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethisSchool.org. Thanks.